Assalamu alaikum. Good afternoon, everyone. Today we'll discuss how the heat energy can transfer from one place to another, the method of heat transfer or heat energy transfer. So heat energy can transfer in three ways, which are known as conduction, convection, and radiation. So when the energy transfer, it can heat energy transfer, maybe it is transferred due to conduction or convection or radiation. So these are the three ways by which energy or heat energy transfer from one place to another. So first, what is conduction? What happens in conduction? Conduction normally occur in solids. And how it happens? As we know, solids, in the solid, the particles are tightly packed together. These are the particles in a solid. So when we supply heat energy, example, if I'm heating end A and holding this object from position B. So if I'm supplying a heat energy to end A, after some time, if it's a conductor, because it's not necessary that all solid allow the heat energy to pass, but if it is a conductor, conductor means the material which allow heat energy to pass through it. So when I supply the heat energy, what it causes the temperature of this material to rise. As the temperature increase, we know temperature and kinetic energy are directly proportional. So the kinetic energy will also increase. As the kinetic energy increase in solid, the particles that cannot move from one place to another, they can only vibrate about the fixed position. So when we supply the heat energy, say this is particle 1, so it will vibrate at a higher speed. When it will vibrate at a higher speed, it will collide with another particle and it will cause the other particle to vibrate as well, the particle 2. Then this particle 2, as it vibrate, it caused the other one to vibrate as well, and then it collided with the last particle here, the fourth one, and this is how we receive the heat energy from one place to another, or transfer the heat energy from one place to another by the actual vibration of the molecule without the actual movement of the molecule or particles from one place to another. Particles are only vibrating, but they are not moving from one place to another. The simple way to understand this, for example, a teacher is holding a book, and this book is example heat. A teacher passed this book to student A, then student A passed this book to student B, student B passes through to student C, then from C it passes through to D, and D it is passes through to E. So actually the book moved from one place to another, but without the actual movement of the students. So students only transfer the book from one to another. So same is happening for conduction, that heat energy transfer from one place to another without the actual movement of the particle, and we call this method as conduction. Is it clear, the concept of conduction? The transfer of heat energy without the actual movement of the particle only vibrate and transfer heat energy. Any doubt in this part? So conduction is a process by which heat is transmitted through a region. Look what happened in conduction. You have a material, a solid material, which is having particles. So when we are heating one end, when we supply heat energy to one end, what it causes, this heat energy causes the particles to vibrate. So this particle, because it is directly exposed to the heat, so it will absorb majority of the heat and it will vibrate at a very high speed. As we know, because the temperature of the material increase, as the temperature increase, the kinetic energy will also increase. So this particle will vibrate. As it will vibrate, it will collide with another particle or a particle next to this. So particle A or particle 1 will cause the particle 2 to vibrate because it is colliding and transferring the energy. Then particle 2 collide with particle 3 and that also causes the vibration. Then particle 3 collided with particle 4 and it also caused the vibration. So actually what happened, the particle remain is not actually moving from one place to another, but the energy transfer from particle 1 to particle 4, this method of energy transfer which happen in solid, we call that as conduction. So in this process, a heat is transmitted through the medium from a hotter part to a colder part until both are at same temperature. And conduction only occur in solid, because in solid the particles are tightly packed together, they can vibrate. So this conduction occur or happen in solids. So what happened? This is the explanation how this. I will go through the points. This is the same thing which I explain now. Molecule in a solid are very close to each other or arranged in a regular pattern. So when one end of a metal rod, or example, a solid is heated, a molecule at this end vibrate faster due to increase in kinetic energy. And this molecule collide with the neighboring molecules and cause them to vibrate as well. And the process is repeated until the molecules of the rod at the other end are also vibrating. Thus, the heat energy is transfer because the internal energy increase. That's why the heat energy transfer from one place to another. But it is not necessary that all solid will allow the heat energy to pass. Like usually metals, they allow heat energy to pass easily as compared to non-metals or polymers. So what is the reason for that? Why in case of metal heat energy can, because in terms of energy transfer, some of the material allow the heat energy to pass from one end to another. If a material allow the heat energy to pass from one end to another, we call them as conductor. But some of the material block or stop the heat energy, does not allow the heat energy to flow through them, and we call them as insulator. So even though both are solid, conductors are also solid, insulators are also solid, but why a conductor allow the heat energy to pass, whereas insulator does not allow heat energy to pass? Normally, the conductors are metals, and these metals, they have a lattice of a positive ion. The ions are tightly packed together, regular structure is there, and the delocalized electrons means there are free electrons which are there within the structure. Electron can be anywhere. So there are two ways by which energy transfer. One is by the vibration of the lattice, in metals, what happened when we supply the heat energy? So when we heat one end, this particle vibrate, cause the other to vibrate, then cause the other to vibrate, and so on. So the heat energy is transferred here by lattice vibration. And the second one is by free electrons as well. Electrons are also there within the structure, so they are also carrying the heat energy from one place to another. But in case of insulator, even though it is a solid, but why they are not able to conduct the heat energy? Because the molecules are larger in size as compared to that in, they are also solid, so regular arrangement will be there, but molecules are larger in size, greater in size. So what happened, as their molecules are larger or bigger in size, so when we supply the heat energy, the amount of heat which we are supplying is causing a vibration, but very small vibration, because it's a heavy particle, cannot vibrate easily. So if it cannot vibrate easily, that is why it cannot collide with another particle or does not allow the heat energy to pass through it. So this is example insulator, example like plastic, rubber. These are examples of insulator. So they are solid, so they have regular arrangement of the particle, but because of the large size particles or molecules, when we supply heat energy, that heat energy is not sufficient to cause the vibration of the particle, as it cannot cause the vibration of the particle easily. So heat is not transferred from one place to another. Yes, glass molecules, if at a low energy, glass is insulator, but if you supply too much energy, then glass is a poor conductor, you can say. So if too much heat energy is supplied, like example, if you take a container which is made up of glass and you put, so if it's a container, for example, it's made up of glass and you put a hot water inside. So this hot water which is inside, if you try to hold this glass, it will not be too much warm, like you can hold it. So reason for that, glass is not a good conductor. It can conduct some of the heat energy, but not a good conductor. But if I take a polystyrene cup, so polystyrene is an insulator, so it can block the energy or does not allow the heat energy to pass from one place to another. So a container which is filled with water, these are the molecules, but what happened? It does not or not able to cause the vibration of the molecules, so not able to transfer heat energy from one place to another. Is it clear the difference between the conductor and insulators? So you can see here, example, you have a metal rod and you're supplying the heat energy. So when you supply the heat energy, what will happen? First, the particles which are directly exposed to the heat, they will vibrate, and as they will vibrate, they cause the other particles to vibrate and transfer energy in both all the directions. It's not like it will transfer energy towards right, left, because the particle can vibrate in any plane. If you have a molecule, it can vibrate horizontally, it can vibrate vertically, or it can vibrate actually in the 3 dimension, it can vibrate. So it transfer the energy in all equally in all the directions. Why insulator cannot conduct heat energy well? Because what happens if we have an insulator, the particle molecules are larger in size. So as the molecules are too big, the molecules are not able to vibrate easily. Even you are supplying a heat energy, like I'm holding a plastic rod and I supply heat energy to one end. So when I supply heat energy, that energy is not sufficient to cause the vibration of this particle, so it does not collide with another particle. That is why this material is known as insulator. Metal transfer heat energy by vibration of the lattice and as well as movement of the free electron. But most of the energy, because we know the metals, the structure of the metals have positive ions. So these are the positive ions of the metal. So most of the energy is transferred by the lattice vibration. What is the meaning of lattice vibration? If I supply heat energy, this heat energy causes this particle to vibrate. This will collide with another particle and they transfer the energy from one place to another. So transfer of energy by vibration of the particle and collision, that's called lattice vibration. This is one way. And there is also another way the energy transfer in the metal, because there is a free electron. So these electrons also take energy and they start to move and transfer energy from one place to another. So in case of metal, both process happen. One is the lattice vibration, another one is the movement of electron. But most of the energy is by the lattice vibration. So example, if you are holding a metal strip and you place above the candle, which lighted up. So when you place it above the flame, you will find that you will feel hot at the other end. Why you feel hot at the other end? Because the energy transfer from one end to another. And there is also another common example. For example, if in winter, say this is a door and you're holding a doorknob. This is a doorknob, door handle or doorknob, you can say. When you touch the doorknob in winter, like now, what you feel, hot or cold in a winter? When you touch the doorknob or you touch the door handle, what you feel? You feel that it is cold. What is the reason why you feel these doorknobs or door handles are mainly made up of metal? So why you feel cold? Actually, doorknob is not cold. So actually, the doorknob is not hot or cold, but what happened when you touch the doorknob? Doorknob is made up of metal. Like example, you touch point A. So what happened? The doorknob, because it's made up of metal, so it will take energy from your body and transfer that energy to the metal. So when this energy is transferred, the part, our hand, which is in contact with the metal, that part will feel colder. So in reality, that doorknob is neither hot or cold initially when you touch, because the metal conduct the heat energy, take the heat energy from your hand. That's why your hand energy decreases, so you will feel colder. Is it clear? So you can see when we supply the heat energy, we cause the particle to vibrate, and this causes the other particles to vibrate as well and transfer the energy from one place to another. A simple experiment, if you want to identify whether a material is a conductor or insulator, some examples of conductors such as copper, aluminum, iron, gold, and insulators such as glass, water, plastic, rubber, wood. How we can carry out an experiment to show how we can carry out an experiment to show whether a material is insulator or a conductor. So a simple experiment to show or identify whether a material is insulator or conductor. Example, we have two objects A and B, or two rods A and B. And I want to find which one is a conductor. One of them is a conductor, another one is insulator. So what I will do, I will put equal amount of candle wax. I'll put a wax or candle wax equal amount on both of these rods. Then I'll supply or give the equal amount of heat energy to these rods. So when I give the equal amount of heat energy to both or each rod, how I can distinguish whether rod A is a conductor or insulator, or whether rod B is conductor or insulator. So if rod A is a conductor, then what I will observe, conductor means allow the energy to pass through it. So it will transfer the energy or take the energy from one end and transfer to the other. As it will transfer energy to the other, what I will observe? I'll observe that the candle wax will melt. So if the candle wax melt, it means it is a conductor. But how I can know that the second rod is an insulator? Insulator does not allow the heat energy to pass through it. So if I'm supplying heat energy, I observe that there is no change in the candle wax. So what it shows, if there is no change in the candle wax, it means this material is insulator. So a simple experiment to identify whether a material is a conductor or insulator. We'll place a candle wax, supply the heat energy to other end. If the candle wax melt, it means it's a conductor, allow the heat energy to pass through it. If it does not, if the wax, no change in the wax, it shows that the material is insulator. What should be the parameters here for a fair comparison? If I want a fair comparison, the things which I should keep constant. For a fair comparison, if I want the experiment to be fair, the distance of the heat supply, that's same length of a rod, that's also correct. Same thickness or same volume of the rod, that's all. Same amount of heat energy, that's also correct. And same amount of wax, same mass of wax or same amount of wax. So for a fair comparison, if I want a fair comparison, I should take equal length of the two rods, same thickness, same amount of wax, same amount of heat energy should be supplied, and same time for the rod. So there are parameters more than 3 which we can keep constant for a fair comparison. Is it clear, this experiment to distinguish between a conductor and insulator? this experiment can also be done to compare the conduction of the, because all the metals are conductor, but rate of conduction is different. So we can also use the same experiment to identify the rate of conduction. So what we can do, example, we have three metal rods, metal rod A, B, and C, and we supply the same amount of energy to each and place an equal amount of candle wax. What other apparatus I need for this experiment? I also need a stopwatch. Why I need a stopwatch? Because using a stopwatch, I measure a time taken by the wax to melt. Example, rod A, the wax took 10 seconds to melt. Rod B, the wax took 3 seconds to melt. And rod C, it took 15 seconds to melt. Which one is a good conductor of heat energy? A, B, or C? So rod B, all of them are conductor because in all cases the wax melt here, but because it took a short time to transfer the heat energy from one place to another, so this experiment shows that the rod B is better conductor as compared to A and C. Again, for a fair comparison, we should take equal lengths, same amount of wax, same amount of heat energy, and heat supplied for the same time interval. A simple experiment to show that a comparison between the different types of metals or metal rod. So these are some examples related to conduction, conductors and insulator. Like you will find all the metals are good conductor of heat. So cooking pans, kettles, electric irons are made up of copper, aluminum, or steel. Whereas plastic and wood, as we know, they are not a good conductor, or they are good insulator. Good insulator means does not allow the heat to pass through easily. So therefore, the handles of the cooking utensils are made of plastic or wood. Air is also an insulator. So how a blanket is keeping us warm in winter. So it trap the air molecules, or same thing when you walk on the carpet, you don't feel that the floor is cold enough or in a winter. So what is the reason for that? Because air is insulator. Insulator means does not allow heat to pass through. So if there's a blanket, it is having a packets of air, small air regions where it traps the air molecules. And air is insulator, or good insulator does not allow the heat energy to pass through. So in winter, what happened? We are not able to lose the heat energy. Why we are not able to lose the heat energy by using a blanket? Because this blanket is having, or it trapped the air molecule. So as it trapped the air molecule, air does not allow the heat energy to pass through easily. So it does not allow the heat energy to pass through easily. So our body will remain warm. Is it clear? The example how air, which is a good insulator, can be used to trap the heat energy and does not allow the conduction to take place. Any doubt in this part? The second method, so this is about conduction, like how a conduction occur. The second method of heat energy transfer is known as convection. and convection, it occur in the fluids. The term fluid means it can happen in liquid. Something which can flow is called a fluid. It can also happen in a gas. So both liquids and gases, the energy transfer by convection. How it happened? Look, for example, we have a container, and this container is filled with water. And these are the water particles. There's a uniform temperature. So if temperature is uniform, it means they will have equal space. And if I supply the heat energy at the bottom, so when I supply the heat energy, the particles gain energy, they will move faster and they will move away from each other. So as the particle move away from each other, what will happen to, as these particles are moving away from each other, the region where I supply the heat energy? So as these particles are moving away from each other, what happened to the volume here, the space in this region, which I encircled here? What happened to volume of this part? As the particle in this part tend to move away from each other. So the particles are moving away from each other, the volume increases. As the volume increase, so three particles in a specific space, they are moving away from each other, the volume increase. So what happened to the density of this group of particles or this part of a liquid? Density is mass over volume. There are three particles. So as the volume increases, the density will decrease. So as the volume increases, the density is decreasing. As the density is decreasing, what will happen when we have a low density object or material? So they tend to rise up. So this part or group of particles start to move up or they start to rise. And when I take the same three particles in another part, when you compare the particles, a group of particles at the top, because these particles are closer to each other. So as these particles are closer to each other, they have a smaller volume. As they have a smaller volume, they have high density. So these particles, group of particles which have occupy a small space or having a higher density, so that part will move down or it will fall or it will sink. So group of particles rise, move up, and another group of particles come down or move down when the energy transfer by the movement of the particles from one place to another, because this group of particles will take the energy and they will rise up, and remaining the second group will come down. So the energy transfer from hot region to cold region by the movement of the particle, and what we call this energy transfer, we call that as convection. So convection is a transfer of energy by the actual movement of the particle due to difference in the density or due to expansion of the fluid. Is it clear? This convection. The particles which are rising, they are hot or cold? How they are heated? We are supplying a heat energy. We can have a burner here. We can use electrical heater. So the particles which absorb energy and they are rising, they are hot particles, energetic particle, and the particle which sink, they have low energy or they are cold particles. So hot energetic particles always rise up and cold and less energetic particles will move down. And this movement of the particle is known as convection. And this happen in the fluid only. So example, in a room, we have air particles. These are the air particles, which are evenly distributed, because if the temperature of the room is constant throughout, so the particles are evenly distributed within the room. You place the heater at the bottom. You place the heater here, electrical heater. The heater supply energy. When the heater supply energy, so the group of the particles, when they absorb energy from the heater, they tend to move away. So as a group of particles which absorb energy and they tend to move away, so what happened to this part of the fluid? The volume will, this part, the volume will increase and the density will decrease. As the density will decrease, volume increases, the part of the, or the group of the molecule will rise up or move upward. And when we compare the same number of the particles in another part of a fluid, because they are closer to each other compared to these particles, so they have smaller volume or high density, so this part of a fluid will sink. And this movement of the particle, in which the heat energy transfer from one place to another, is known as convection. So convection occur by the actual movement of the particle. Conduction only happen by vibration and it happen only in solid. But convection can happen or occur in liquid, or it can happen in gas as well. Is it clear the difference here, how the energy transfer by the actual movement of the particles? So how convection occur in a liquid? You can see here, these are the container which are filled with liquid. So when we supply heat energy, the group of particles which absorb energy, they will move away from each other, density decreases, so they will rise. And the other group of particles which are closer to each other, they will move down, and this movement of the particle is known as convection current. Means the hot particles move up and the cold particle move down. This movement of the particle is known as convection current. And how convection happen in air? This we already discussed. Now the everyday applications. Now in this case, you can see, like example, here you have a smoldering string, which is a source of smoke. So if we supply the heat energy, so the particles, group of particle absorb energy, they will move away from each other, density decrease, so this will rise. So if we have a particle here, a smoke particle at this point, which direction it will move? A, B, C, or D? If we have a smoke particle and we light up a candle at the other end, which direction this smoke particle will move? A, B, C, or D? What will be the direction of the movement of the smoke particle?